Introduce to you Jane Lee, Huawei CEO, as a keynote speaker on the next 40 years of Ethernet. Ms. Lee has previously worked with Huawei Symantec as a storage system, and before that she was Executive Vice President and General Manager with Lightwave. She holds a master's degree in telecommunication engineering from Zhejiang University, and it is my honor to introduce her as our keynote speaker.
Thank you, Sergis. I think I really like the person you introduced to us. Good afternoon, everybody. I'm certainly very humbled to be up here to share with you my thoughts on the future of Ethernet, a remarkable technology that has transformed how we work and how we live in the past 40 years. Before we do that, this is the 40th anniversary of Ethernet. I thought we should share a round of applause to everybody in this room who has done a marvelous job for this technology and create an Ethernet community. I got all these meetings coming up. My apologies for trying to figure out how to move the slides. Sorry, folks. Maybe it's not on Ethernet.
No, it's definitely not Ethernet. It's me. Let's try this again. There we go. So good. Already sorry about that.
Here we go. So before we talk about the next 40 years of Ethernet, it certainly feels right to pay the tribute to the gentleman who invented it 40 years ago, Bob Metcalfe. When I was thinking about that, I wondered, when Bob invented this great network to connect the multiple PCs to a printer, whether he thought about what the impact of this technology will create in 40 years. But we know one man did, and he did that in 1983. So now many of us, or at least myself, still want to grow up to be Steve Jobs. In 1983, Steve Jobs gave a speech at the event called the International Design Conference in Aspen. His prediction of the growth of PCs, wireless network, and home network were certainly spot on. So in preparing for this presentation, I thought it would have been great if I could get Steve's advice as well. Since Steve is not here, I asked Siri for some guidance for the future of Ethernet. So Siri first asked to think about it. Then she took a short pause. Then she suggested she could search the web for me for the answers. So that didn't work out very well. But luckily, I got a backup plan. This incredible group of thinkers and innovators from the industry have come to my rescue. Collectively, we would like to share with you our vision of where the Ethernet will go and how it's going to continue to change the world around us. I'm sure many of you in this room know most of the folks down there, and because of the time constraint, I won't introduce them one by one, but my appreciation for their thoughts in the preparation of this presentation. So I also hope you don't mind, before we look at the Ethernet crystal ball, I talk a few minutes about Huawei. Who recognize this garage in this room? Quite a few of you. And you should, because this is named the birthplace of Silicon Valley. And you're right, it is the HP garage where Bill Hewlett and Dave Packard started their astonishing journey. Now, those of us who love Silicon Valley love the garages. It just seems to us that a lot of the great companies are created in garages. So in Silicon Valley, even a garage can be glamorous, I guess. 40 years later, after the birth of Silicon Valley, in Chinese government created its first special economic zone in a fishing village called Shenzhen, and that was 1979. Few years later, a gentleman called Mr. Ren Zhengfei started a company called Huawei with about $3,000. So even though there was no garages in Shenzhen at that time, still there are not many garages in Shenzhen today because most people live in apartments. Huawei was, and still is, the HP fairy tale for many Chinese entrepreneurs. So this is Huawei today, a little bit bigger than $3,000 with annual revenue of $38.7 billion, 26,000 patents, 25 innovation centers globally, and 70,000 R&D staff globally. These are some of the major milestones Huawei has accomplished along with that $38.7 billion revenue. Number one in telco infrastructure, number two in video conferencing, carrier switches and routers, and the most recent achievement is the third place for smartphones. So while it has been exciting for a technology company headquartered in China to accomplish these great milestones, what we are mostly excited about is how these milestones can help us to accomplish our next mission. Huawei believes the world of information technology and the world of communication technology will converge to create the ICT infrastructure. Cloud computing and BYOD require integrated platform of compute, storage, network, optical, wireless, and mobility technologies at a global level. Our leading positions in both information technology and communication technology put us in a unique position to help creating the ICT platform where the future Ethernet will be riding on. Now, even for a $40 billion company, creating the global ICT platform sounds like a daunting task. Fortunately, we have other pioneers who have shown us the way in other industries. Toyota globalized the auto industry in 1980s. Southwestern Airlines brought quality and value to air travel. Apple and Samsung have taken cell phone industry to a whole new playground. These folks led the transformations that have changed the way we drive, we fly, we talk, and the time has come for us to work together to change the way we compute. And now it's time for us to talk about the crystal ball of Ethernet. Now, you probably have seen many network speed roadmaps before, but you probably have not seen a version that goes as far as 2053. So you're seeing this the first time live. Data center speed is exploding and will continue to do so. Meanwhile, wireless will continue to drive the growth of the edge network. We in general would like in this presentation to look at the next 40 years in two stages, 2013 to 2033, 2034 to 2053. So I'll simply refer them to the terabit era and petabit era. We predict the data center speed will reach 10 terabits per port, while the wireless LAN will reach hundreds of gigabit per port by 2033. By 2053, data center will reach petabits and the wireless LAN will reach 50 terabits. The question is, therefore, what are we going to do with the terabit network? We all know video is going to be a huge driver for the next 20 years, so I'm showing an example of that. Consumers will no longer be happy about playing Skype video anymore. So this is a picture of a concert that happened in Coachella. You probably noticed Snoop Dogg and Tupac are on the stage together. And how did that happen? It was through 3 projectors of 1 terabit live video stream. The artists and the IT professionals have made this become a reality. People want more and more the experience of being there by not being there. Technology perhaps will make it harder and harder to differentiate illusion from reality, and hopefully that's a good thing. The next big application, you probably haven't missed this throughout the conference, is big data. When we talk about big data, we always think of Facebook. Even though the Facebook nation has 1 billion people now and 1 trillion connections, Facebook only represents the beginning of the big data, actually. But we have already seen the amount of traffic it has brought to the network. Now, big data and the video growth are also interconnected, as young generations seem to have replaced the numbers with videos. A good example is my daughter seems to spend much more time on YouTube than doing math. So IDC believes big data hasn't exploded yet because the new generation of sensors haven't taken off. When that happens, we will see a lot more applications and a lot more data and its analytical results to be put on network. So that will be really cool. A lot of applications can be generated from that. One of the things I can think of is it might be cool to get up every day before get on a 280 highway to go to work, figure out how many BMWs are on the road. And it will be possible. So the next question, of course, is what are the technology elements we need in order to handle the terabit content? The first barrier we need to break is on the device level. Copper will no longer be sufficient to handle that kind of data rate. The new generation of silicon photonics have promised to bring optical networking capability that's traditionally only seen in long-distance networks to the chip level, and that is very exciting. The next example of technology that's going to help us handle the terabit data is switches on processors to enable servers to scale out at such high data rate with very low power consumption and latency. So the interesting part is, while on the hardware level we need to drive up the performance and speed, on the software side we actually need to simplify. SDN, another topic you probably couldn't miss in this conference, is going to be critical so we can virtualize the network, eliminating the proprietary codes and make the network a lot more user-friendly. Server virtualization has shown us many benefits of virtualization. SDN can bring similar benefits and complete end-to-end virtualization to make it a true global bare metal network that we want. I know many of us in the room like networking a lot, but I trust with SDN, perhaps you will not be encouraging your children to be a CCIE, or for Huawei, it's HWIE anymore pretty soon. So we are at an inflection point that we will see a lot faster transitions, not only in technologies, which was the focus of previous slides, but also in the players and the business models. So this is a slide showing it took Bell almost 100 years to change their business model and to eventually break up, and AT&T was born. But we predict the next powerful combination in order to drive data center and cloud computing growth will come a lot faster. Data center operators need to be consolidated so they can be managed more effectively. This type of combination, Verizon, Amazon, Apple, AT&T, Microsoft, Sprint, will also empower more service variations that will allow business and consumers to be able to enjoy more and more one-stop service or one-stop shop. By the way, my personal favorite is Verizon, once I figured out how to pronounce that. It just sounds cool. So the other interesting part of that is it will also change your utility bills. Now luckily you will still have 4 utility bills, but it's not going to be electricity, water, gas, and phone. It's going to be electricity, water, gas, and cloud, or ICT. So that was the first 20 years. And now we come to the terabit era. So the terabit era actually was a lot more fun to work on because we could run more freely with our imagination. In a way, it actually feels like sci-fi movie creation. I'll show you why. To start discussion for the next 20 years, we need more compute power. What seems to be supercomputing powers today will have to be available on our desktops or tablets by that time. So if you start by looking at the background of this slide, it is the Titan supercomputer today. Many of you probably recognize at Oak Ridge National Laboratory. With 17.59 petaflops, it's ranked the #1 on top 500. Here's another roadmap I would like to share with you. Again, you've probably seen many, but this is probably the first one that goes to 2053. And it's highlighted by data center compute power that takes us to geoflops. Now, that is a real word. I didn't just make it up. The computing power on desktops will evolve quickly as well. AMD promised the 10 teraflops notebooks by 2020. And that's only the beginning. I think before 2053, you will have a Titan in your living room. Interestingly, a single guy's furniture style won't change much in the next 40 years. But luckily, his power to compute will. So the next question is, what you are going to do with this much compute power? For one thing, you can bring the hologram 2-pack live concert to your living room. So that's cool. But there are many other great applications for this. You will also now be able to allow your in-laws to be in your living room, but actually never feel the physical presence. Some of you might find that pretty helpful as well. So I think the most interesting thing about 2033 and beyond, what the network can do, is something very different. For a long time, we have been using technologies mostly to better the quality of human lives. But it is possible to take the next leap of faith. It is exciting to think about the possibilities of letting network become part of our lives or extended lives. Ethernet technology will reach another growth spur when humans start to join the network. The general technology term for that is called BCI, Brain-Computer Interface. Human brains are actually the most amazing supercomputer in the switch. Each human brain represents 100 billion neurons, 100 billion connections, and with all that compute and switching power, only consumes 12 watts of power. And if you remember the early slides, Facebook actually only represents 1 trillion connections. So it is also projected that by 2050, we'll have 10 billion human beings on Earth. So imagine put all these humans on the network, how much traffic that will generate. Today, we are at the beginning stage of the BCI technology, actually. Scientists are trying to figure out how the brains control motions of our bodies. The next step will be a medical breakthrough. A chip can be implanted in the brain via wireless LAN. The brain can now start to control the motions of prosthetic limbs, for example. Of course, at the meantime, everything can be stored and managed in the cloud at the same time, and upgrades can also come from the cloud, so you get a better arm or better leg with a click of a button. The next stage is for the scientists to figure out how humans make emotional and social decisions. Then perhaps we are much closer to create real human beings. Well, that also means we need much more compute power and networking speed to leverage these discoveries and to put human brains on the network. Now, I borrowed this slide from the Avatar fan club. They're showing a much more aggressive projection on how to get to Avatar V. But in real life, as scientists figure out step by step how our brain functions, we will see a lot of brain work that will be carried out in the cloud, in the supercomputer that will be implanted in human bodies, and between these two technologies. If you remember our network speed roadmap, the second 20 years will be the petabit era, and the avatars will be really thankful that we have the network performance to make their lives fulfilling. If the first biggest challenge for human beings is for human beings to understand ourselves, then the next biggest challenge is how we interact with each other. Perhaps future generations will see network continue to play a critical role beyond the 2053 in building a true human network, whatever medium that's going to take place in, and stay connected and communicate much more effectively. I'm afraid that's all the time we have today to talk about the next 40 years of Ethernet. Some of the ideas might seem to be crazy to you, but Facebook might have seemed to be a crazy idea to people perhaps 40 years ago. Our right to dream might be our best attribute that computers can simply replace. Now, if you want to continue the dialogue, we provided the link here, surveymonkey.com Ethernet time capsule. So get online and cast your vote, and would love to hear your opinion, and we'll send you a copy of the results. Last but not least, while many other networking technologies have become something in the past, Ethernet community has done a great job in creating a technology platform that not only excels in speed, but also is exceptionally open, compatible, and ubiquitous. This tradition will continue to be critical for the next 40 years of Ethernet evolution, and I'm sure will be carried out to the next level by many of you in this room and online on the webcast. Thank you, everybody. Enjoy the next 40 years.